Hi everyone, in today's lesson we're going to talk about probability concepts. The first concept is called the fundamental counting principle, and it states that if there are p ways to do one thing and q ways to do another thing, then there are p times q ways to do both things. So long story short, the fundamental counting principle allows us to calculate multiple events happening at the same time and how many possibilities they'll have. So let's look at example number one. We say Miss Mangine goes to the concession stand at Yankee Stadium and sees the following menu. So chicken fingers is my first entree choice. I know it looks like two, but it's one. It just got copied weird. Hamburger is my second, veggie burger, and then hot dog. So I have four entrees to choose from. I have three sides, and I have 5 drinks to choose from. So my question, draw a tree diagram to determine how many different options I will have if I can order one entree, one side, and one drink. So a tree diagram is a great visual representation of what we have going on. So I'm going to use C for chicken fingers, and I'm going to put that here. Then I'm going to put hamburger here. I'm going to put V for veggie burger, and then I'm going to put D for hot dog. So those are my four options for entree. Then each of those four options have three side choices. So I can get French fries. I'll put F for French fries. I can get tater tots, T for tater tots, and C for chips. Same here. I have three options. French fries, tater tots, chips. French fries, tater tots, and chips. And then last but not least, French fries, tater tots, and then chips. And then last but not least, I have 5 drinks to choose from. So what that means is that each one of these branches must get 5 different choices for a drink. This might get a little squishy for your work, but that's okay. We'll do the best that we can. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. And I'm going to do this right. So obviously this one is a poor example because there are so many choices. So this is actually a really good observation to see how a tree diagram is actually not as effective, because if I miscount any one of these lines here, then I'm not going to be able to figure out my options. But I can actually use this to find a pattern and then just multiply. So let's just say I get chicken fingers, right? Then I get French fries, and then I get a Coke, right? This line would be Coke. I didn't label them all, but let's just say Coke, Diet Coke, Sprite, water, and iced tea. So if I highlight in yellow, that is my first option. I can get a Coke with French fries, and then, I'm sorry, chicken fingers, Coke, and French fries. Then if I keep doing this, with chicken, I could do chicken fingers, French fries, and a diet. Chicken fingers, French fries, and a Sprite. Chicken fingers, French fries, and a water. Chicken fingers, French fries, and an iced tea. So with just chicken and French fries, I have 5 options, right? We just kind of calculated them. 1, 2, 3, 4, 5. So if I have 5 options here, I'm likely to have 5 options here, 5 options here, 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 here. So all I would really have to do is just say, okay, there's going to be 5 here, 5 here, 5 here, 5 here, 5 here. And all I would have to do is add up all of these possibilities, and that would be all of the number of options that I would have. So let's count how many 5s we have. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. Oh boy. So I have 60 options when I'm ordering at the concession stand. Now, I would hope that there's an easier way that we can do this, because drawing a tree diagram for 60 options is a little bit excessive. So there's actually something we can use, and we can use the counting principle like I discussed before. And the counting principle works like this. We would draw 3 lines for the 3 different options that we have. So we have entrees, then we have sides, and then we have drinks. And all we would have to do is multiply the number of possibilities for each one. So how many entrees did I have? Well, I had a chicken fingers, hamburger, veggie burger, and a hot dog. So there are 4 options for my entrees. How many sides did I have? French fries, tater tots, and chips. That would be 3. And then how many drinks did I have? Coke, Diet Coke, Sprite, water, and iced tea. I had 5. So all we'll have to do is multiply 4 times 3 times 5, and that will give us the number of options. So take a minute, pause the video, do 4 times 3 times 5 in the calculator, and see if you get 60, and then hit resume when you're ready to continue. All right, you definitely should have gotten 60. So 60 options. Much, much easier than drawing a tree diagram. So I'd like to continue to use the counting principle moving forward. All right, now what if I want to use the counting principle to determine how many orders I can get without meat or diet? So I don't want to eat meat, but I don't want to drink diet soda. So now it goes down the same kind of concept. I have entrees, then I have sides, and then I have drinks. And I want to multiply them together. Well, how many entree choices do I have if I'm not eating meat? Well, I can't have chicken fingers. I can't have a a hamburger. I can have a veggie burger, but I can't have a hot dog. So I literally only have one possibility for my entree, and that is the veggie burger. For my sides, I can have a tater tot, I can have a French fry, I can have chips. So that's 3 choices there. And for my drinks, I said I don't want diet soda. So I have Coke, Diet Coke, Sprite, water, iced tea. So I just don't want the diet. So I have a Coke, Sprite, water, iced tea would leave me with 4 options for drinks. So if I multiply this together, we would get 1 times 3 times 4 is actually only 12 possibilities. So when you significantly reduce the number of options that you are choosing from, your possibilities will go down drastically. And that's just a good observation for us to see. All right, let's move on. All right, so I'd like to discuss what a permutation is. A permutation is a way of organizing objects in a specific order. So that's the most important part from this, specific order. A permutation has order. Permutations work the same way as the counting principle, so that's important to know as well. There is a way that we can calculate questions using a permutation. So the mathematical symbol for permutation is like this, NPR, where N is the total number, and it could be a total number of people, it could be a total number of objects, and R is the number of groupings that you would like. And this will make sense as we do an example. And I'll show you how to use it in the calculator as well. So let's look, example number 1. It says, how many different ways can 3 students run for president, vice president, and secretary in the next student election? So I have 3 students, and I want them to run for president, vice president, and secretary in the next election. So I have 3 total number of students, and I want 3 groupings. Those groups are president, vice president, and secretary. So those are my 3 groups, and these are the total number that we started with. I have 3 students. So if you wanted to put 3p3 into the calculator, you would actually hit the math button, and you would scroll over to probability, and you would see the option for NPR, and then type this in just the way you see it. If you can't, that's okay. We can go through it tomorrow in class. But if you did and are able to do that, the answer is 6. So we have 6 possible ways that we can make these 3 students run for president, vice president, and secretary. Now, we could also use the counting principle. President, vice president, secretary. VP, and secretary. So how many students do I have available to run for president? 3. So we would put 3 here. Then if one person is already taken as a president, I only have two people that could be my vice president. And then once I select a president and a vice president, I only have one person left over for my secretary. So therefore, that answer multiplies to 6. So this concept of 3p3 is actually the same thing as 3 times 2 times 1, or this counting principle. Let's talk about a combination. Now, a combination is a way of grouping objects without a specific order. So I don't care who's first, second, and third. I just want people in a committee or in a group, but the order doesn't matter. So we're going to use the same formula, except this time we're going to use a C. So it's NCR, where N is your total and R is the number of groupings. So let's read this and see how it's a little different. So it says, a pizza shop has available toppings: onion, mushroom, sausage, bacon, olives, pepperoni, and anchovies. How many different ways can pizza be made with 4 toppings? Well, this is clear. The order doesn't matter. They're not saying specifically on a half of the pie or a third of the pie. They're just saying how many different ways can it be made with the 4 toppings. We throw all the toppings on the top and we don't care, what order they're in. So, well, let's see how many toppings we have so we can find our total. So 1, 2, 3, 4, 5, 6, 7. So N is 7. That's my total number of toppings. And I want to know how many groups of 4 can I make. So my R value would be 4. So 7, C4. This cannot be done using the counting principle, so you will have to use the calculator. So again, you're going to hit math. You're going to go over to probability, which I believe it's just PRB. And you're going to hit, I believe it's choice 3 for the combinations. It should say NCR. And then go ahead, type that in, and then hit resume when you're ready for the answer. All right, so you should have gotten approximately 35 different pizzas that could be made. If you're having trouble with the calculator steps, that's okay. We will definitely go over it in class tomorrow.
All right, that's it for today. If you have any questions, please jot them down and make sure you ask us in class tomorrow. All right, have a good night.